Okay, good afternoon. So for today, medyo magdi-discuss tayo at medyo marami tayong i-discuss kasi we'll have to catch up with many topics that we need to discuss. Okay, in preparation for your quiz din on Wednesday. Although since ilang weeks tayong hindi nagkita, I am expecting and these materials naman have been made available to you early on. I am still expecting that you have read most of the materials here, okay, and have an idea of what of the things na i-discuss natin in the next few hours. Okay, so again, in a few weeks back, pagka pinopost ko itong mga topics na to, I am reminding you, even during yung mga natin, I was reminding you that you have to read these materials in order for you to study them and in order for you to and then work on your homeworks. Okay, so hindi excuse yung hindi tayo di-discuss, but still i-discuss natin yung iba para ma-clarify nyo rin kung ano yung mga parts na hindi niyo na-appreciate ng buo. Okay, so we start with system modeling. Yeah, we start with system modeling. Okay, so essentially, teka, wait lang, wait lang Silent lang. Okay, so basically, in the previous discussion, analysis and design that included the system schematic and demonstrated, and we have demonstrated this step for a position control system. Bali, itong discussion na to was covered ito. Yung sinasabi previous discussion na to, okay, which discussed the analysis and design sequence. Okay, we're covered here in lesson 1.4. Okay, so andyan yung 6 steps in the control design process. Okay, so merong isang part dito, itong step 3, which requires you to transform the physical system into a schematic, and then after that you would have to use that schematic to obtain a block diagram, signal flow, or state space representation of your system. Now essentially, nandito tayo dito sa lesson 2.1. This actually talks about step 4. Okay? So we're dealing with step 4. Step 4 of the control system design process, which again you can refer to lesson 1.4. Okay, so doon nga sa step 4, okay, is to develop mathematical models. Okay, you need to develop mathematical models, okay, from the schematics of physical systems. Okay, so ang sinabi nga doon is that you develop a block diagram, a signal flow graph, or a state space representation. Okay, yan yung tatlong ways by which you can develop the mathematical model of your physical system. Okay, ngayon dito sa lesson natin dito, it specifies that 2 methods may be applied. So either we develop transfer function in the frequency domain, or we develop state equations in the time domain. Okay? Ngayon, in relation to to these three mathematical models that were specified by by the control system design process, ang transfer function can lead to a block diagram or a signal flow graph. So, ibig sabihin, kapag nakakuha tayo ng transfer function ng inyong system, okay, we can actually draw a block diagram representation or a signal flow graph of such system. Basta meron tayong transfer function. Okay? Maliwanag yan? Okay. So, ayun na nga, no? So, yung transfer function natin can lead to a block diagram or a signal flow graph. Now, the other way of developing a mathematical model for your physical system is by the use of state equations. Now, state equations lead to state space representation. Okay, so yung state equations natin will lead to a state space representation for your system. Now, actually, ang state equations or ang state space modeling, okay, yung procedure behind this is called state space modeling. Okay, is actually a newer approach in newer and advanced approach in developing models for your physical system. Okay, this is much more newer than the use of transfer functions. In fact, yung classical control methods or control systems engineering control systems theory natin actually covers yung transfer function. Okay, but with advances in math and in computation or in computational power of our computers, na-develop na rin or nagagamit na rin natin yung state space modeling as a newer, better, and much more advanced way of specifying or of modeling your physical system. Okay? So, but just a reminder, since we are studying control systems on an entry level, or since ito magi-start pa lang talaga tayo to study your control systems. Okay, dun muna tayo sa classical approach, in which we will have to concentrate or focus more on transfer functions. Okay, pero one way or another, baka daanan natin ng or supposedly dapat madadaanan nyo ang state space representation sa laboratory. But since walang katapat na laboratory itong klase na to, so it's either kung tapos na kayo, nadaanan nyo siya doon, o kaya kung hindi pa, you would have to go through it sa laboratory class niyo in the future. Okay. Now, it should be remembered, this is a very important reminder, that it should be remembered that in any case, the first step in developing a mathematical model, is to apply the fundamental physical laws of science and engineering. Okay? So if you're modeling from scratch, ibig sabihin galing talaga kayo sa schematic nyo, papunta kayo sa model. You have to apply these fundamental physical laws of science and engineering, which, for example, pag ang pinag-uusapan natin ng electrical networks, which we would have to deal with kapag nagde-design tayo ng isang automatic control system, so kailangan na pag-usapan yung electrical networks, then we will have to use Ohm's law, or we will have to be a master of Ohm's law and Kirchhoff's law. Okay? And if you're dealing with mechanical systems, with systems that that involves motion, okay, then you would have to use Newton's law, yung first law, second law, tsaka third law ng motion. So we'll have a practice on that later on pagka nag-usap na tayo dun sa part na yan. Okay? So, from previous courses, it can be seen that a differential equation, okay, can describe the relationship between the input and the output of the system. Okay? So the form of the differential equation and its coefficients are a formulation or description of the system. So, ang ano natin, ang models natin start with differential equations actually. Okay? But the problem is that differential equations are not a satisfying representation from a system perspective. Okay? What we want to achieve, or what we want to have our model possess is yung tinatawag na intuition. Okay? We would like our we would like our model to offer some kind of an intuition, okay, in terms of how it is being specified. Okay? So ang gusto nating tipo ng mathematical model natin is that we will be able to separate yung input, yung output, at saka yung system. Okay, such as what we are seeing here. Kung ano yung nakikita natin dito. Okay? So, gusto natin na separate yung signal niyo para sa input, yung output, iba yung representation din yan. Tapos, iba rin yung representation ng system natin. Okay, the problem with differential equation is that you will not be able to separate especially yung input at saka yung output because they are in the same equation. Okay? So kung magde-devise man tayo ng way to specify our system as a mathematical model, we will prefer that this model can separate the three entities, yung input signal, yung output signal, and the system itself, so that mas madali yung pag-manipulate or pag-aano sa kanila mathematically. Okay? So that is why we will actually abandon the use of differential equations at least in this course. Okay? Although ipapakita natin yung relationship ng differential equation sa transfer function. Okay? So actually yun yung na-achieve natin when we are using transfer function as a way to specify our system. Okay? So if you specifying a system as a transfer function allows for separation of the input signal, the output signal, and the system mathematically. Yan. So nasa-separate natin sila. Okay? And what is more convenient with the use of transfer function is that it also allows us to actually interconnect systems, and it is still mathematically convenient para sa atin to manipulate interconnected system. Okay? So another thing about the transfer function is that it allows for interconnection of systems with mathematical convenience. So kumbaga, hindi tayo magde-develop ng separate method. Okay? In order to analyze systems that are interconnected. Okay? So yun yung mga advantages of using your transfer. Okay? So we just remember that in this figure, okay, as your reference or reference input, okay, while C of t would refer to your control variable. Okay. Ginagawa rin natin dyan, yung R of t is said to be our input. Okay. And C of t is said to be our output or response. Pero yung paggamit ng variable kasi na C, okay, means na yung signal na kinokontrol na we wish to control or yung quantity, okay, that we wish to control, okay, is the variable, okay, the variable C, okay. So a major advantage of frequency domain modeling is that they rapidly provide stability and transient response information. Okay. So major advantage of frequency domain modeling is that they provide stability and transient response information. We will not really have to develop very new tools, mathematical tools, in order for us to we will have to develop pala new tools in order for us to obtain stability information and transient response information. Pero yung mga i-develop nating tools and methods are not really that are actually not really that complicated. Okay, since nag-involve lang naman siya ng mga algebraic methods. Okay. So that is why malaking bagay na we will use transfer functions in order to model our system. Okay? Yun nga lang, the problem with that is that the problem with your transfer function, okay, is its applicability. Medyo limited siya. Okay? Dahil i-limit natin yung application natin, okay? Or yung i-limit natin yung application ng transfer function sa linear time invariant systems, okay? Or yung mga pwedeng i-approximate as linear time invariant systems. Isa pang limitation or isa pang limitation nung ating transfer function modeling is that we will have to consider the initial conditions to be 0. Okay? Now, modern control systems nowadays are actually more complex than they were before. Okay? So that is why marami sa mga control systems na dine-develop ngayon are actually non-linear. Okay? But most of them are time invariant. Okay? Ngayon, ang maganda naman minsan is that there are non-linear systems that can be approximated as a linear system. And then with a few corrections, we will be able to use transfer functions to model them. Okay? And yung magiging actual performance naman niya hindi naman malalayo dun sa ini-expect niyo using yung transfer function modeling. Okay? Ang problema lang din is that minsan itong mga systems na to ay masyadong complex that they are really not that paano bang word doon? Yung hindi niyo siya kagad ma-linearize. Hindi siya kagad ma-approximate as a linear system. So pagdating doon magkakaproblema talaga tayo with the transfer function. Okay? Also, ang isa pang limitation kasi ng transfer function niya is that they are limited to what we call single input, single output systems. Ibig sabihin, isa lang yung input signal sa system niyo tapos isa lang din yung output signal. Okay? But most systems nowadays are or have multiple inputs and multiple outputs. So kapag meron na kayong systems that are multiple that have multiple inputs and multiple outputs, medyo magiging complex na rin yung modeling process niyo pagka ang ginamit niyo pa rin is transfer functions. So therefore, minsan, yun na nga, kapag talagang masyado ng komplikado yung system, we are actually ditching the use of transfer functions papuntang yung state space representation. Kasi the state modeling can actually handle almost all systems, whether they are nonlinear, they are time invariant, they have non-zero initial conditions, they have multiple inputs and outputs. Okay? Those cases can be handled by your state modeling or state space modeling. Okay? Ang disadvantage lang para sa atin, ang disadvantage lang ng state space modeling is yung kanyang complexity. Okay, so yung mathematical complexity nung state space modeling natin maybe baka hindi pa tayo masyadong ready as of now. So therefore, doon muna tayo tumingin sa transfer function kasi mas madaling i-absorb yun. Now, ang importante sa atin ngayon is maintindihan natin yung konsepto ng modeling at yung konsepto ng design, okay? Ng analysis pala muna and then yung konsepto ng design, okay? So that in a later time na maisip ninyo, for example, na mag-aral ng Advanced Control Systems Engineering at kailangan yung daanan ng state space modeling, naiintindihan nyo na yung basic things or basic na mga pag-uusapan kapag nagde-design tayo ng mga control systems. Okay? So, I hope everyone is okay with that. Okay? So, saglit lang class kukuha lang ako ng water. Okay. So, proceeding, let's review. Okay. Okay, so let's have some review of the Laplace transform. Kasi critical ang Laplace transform in terms of the discussion of transfer function. Okay, in fact, ang transfer function nyo is actually a model of your system specified in Laplace transform. Okay? So that is why kailangan natin pag-usapan muna yung Laplace transform. But this is just a review of the topic since supposedly dinaanan nyo na ito sa advanced engineering mathematics niyo. Okay? And this is one of the major topics or one of the topics that you have discussed within the Laplace within that course. Okay? And by the way, that course is a prerequisite course of this course. Okay, so therefore, again, ang expectation is alam niyo na dapat ito. Okay, but let us have a little review. Okay, so the Laplace transform, okay, is defined as follows. So it is the integral of f of t times e raised to negative st dt from 0 to infinity. Okay? So, first thing, yung function nyo, f of t, okay, is in time domain. Okay? While yung Laplace transform niyo is in f of s. Yung Laplace transform niyo is specified as f of s, which is in s domain. Okay? So, unang-una, in terms of notation, gagamitin natin yung lowercase variable name, okay? Whenever we are dealing with the variable in time domain. Okay? So, say for example, yun nga, yung variable nyo, the variable is f. Okay? So, we will use the small or the lowercase f to denote the function is in time domain. Okay? While, pag kinuha natin yung Laplace transform nito, okay, yung ating variable name na f, okay, which is in lowercase, becomes the uppercase f. Okay? Whenever we are on its Laplace transform. Okay? So, magiging uppercase siya. So, lowercase pag time domain, okay, uppercase ang gagamitin natin pag S domain. Okay? So, hopefully, malinaw sa atin yan. Okay? So, most of the time, ganyan yung ganyan yung kailangan natin sa notation natin. Okay? Now, talking about S as the S domain, okay, the S variable here, okay, yung independent variable ng inyong Laplace transform is actually a complex variable. Okay? So kung complex variable siya, it means it has a real part, sigma, plus an imaginary part. Okay? Which is omega. Hindi yan W, omega yan. Okay? So, yun, this is how we should understand yung S, especially pagdating sa later part ng ating mga topics where kailangan natin ngayong i-specify na complex siya. Okay? Since we will be evaluating later on transfer functions in the complex domain. Okay? Also, another part of our notation is this symbol. Okay? Which denotes Laplace operation. So, yung script L, we call it script L. Ayan, we call it script L. It means that we are taking the Laplace transform of your f of t. Okay? We are taking the Laplace transform of your f of t. Yun yung ibig sabihin nito. So, if you're taking the Laplace transform f of t, that should equal to f of s. Okay? So, yun yung mga notation natin. So, yung script L here, okay, this script L denotes the Laplace transform operation. Wait lang class may nababother lang ako sa ano ko, sa buhok ko. Wait lang. Okay. So, ayun now, the inverse Laplace transform is defined as this one. Okay. So, where we remember that u of t, okay, is the unit step function. So, napag-usapan din dapat yan sa advanced math class ninyo. Okay. Which is defined as 1 whenever t is positive. Okay. And 0 when t is negative. Okay. So, remember that kung ganito yung tipo ng function niyo or kung ganyan yung function niyo. Okay? Whenever you multiply any quantity or any function with this kind of function, take note that it would yield a function, okay? The product would be a function that is 0 for negative values of t. Kasi 0 siya pag negative yung t . Okay? 1 siya pag positive yung t. So therefore, it retains the value of your function when t is positive, okay? While the function or while the product makes the product is 0 whenever t is negative. Okay? So itong function nyo na ngayon, okay, is yun na nga, that function has a value of 0 whenever t is negative, okay, and 1, f of t, okay, when t is positive. Okay, so anyway, yung mga yung definition na yan is actually later on medyo ma-dissolve yan sa discussion natin kasi in most of our discussion, we will deal with functions that work this way. Okay, so that is we are not really concerned with the value of your function at negative values of t. Sa practice, ang ibig sabihin kasi noon is that, say for example, meron kang machine. Okay, meron kang machine. Yung machine natin, okay, once na switch on mo siya, okay, the moment na switch on mo siya, halimbawa ito yun, this is time By the way, yung din drawing kung ano that is time. Okay? Now, halimbawa, ito yung moment na switch on mo siya. So, switch on. Okay? Ito yung point na yun. Okay? We consider this in mathematical analysis as itong point na to as time 0. Okay? So, yung point na yun, kung kailan mo switch on yung machine mo, for example, that's time 0. So, therefore, after that time, yun na yung tinatawag nating positive time natin. Okay, that is what we consider itong segment na to ng timeline natin. Okay? That is what we consider as your positive time. Okay? But on the other side, okay, yung mga nangyari, okay, yung mga mangyayari before you switch on the machine, okay, is what we call yung negative values of time of negative time. So, ito yun. Okay? Now, some more advanced control systems analysis, meron tayong kailangan kunin pa ring information dito, which is what we call yung initial condition. By the way, kasi baka magtaka kayo, ano yung negative values of time? Wala namang negative time. Yun ang baka pwedeng itanong sa akin. Okay. So, yung tinatawag na negative values of time is actually relative. Relative siya dun sa kung kailan nyo sisimulan yung analysis nyo. Okay? So, in the case of a machine that is being turned on, sisimulan natin i-analyze kasi yung behavior ng machine niyo dun sa point na binuksan nyo yung machine niyo. So, anytime after that is positive time. And anytime before you open your machine is negative time. So, yun yung sinasabing negative time. Relative siya actually. Now, as I was saying, yun negative values of time ninyo sa mas advanced na study ng control systems. May kinukuha tayo diyan initial conditions kasi kino-consider siya especially some of the systems might have initial conditions. Okay? But for us, since we are studying again, we are studying control systems engineering in an elementary level pa lang, okay? I-consider natin tong initial conditions na to be zero. Okay? So therefore, ang gusto nating sabihin dito is that most of the time na mag-a-analyze tayo ng system, okay? Mag-a-analyze tayo ng system. Wala tayong pakialam kung ano ang state ng system ninyo bago nyo buksan yung machine. Okay? We don't really care what is the state of your machine before it is open. Okay? Ang assumption natin is that walang nangyayari, okay? Walang nangyayari sa machine niyo bago niyo siya buksan. Okay? Yun yung assumption na gagawin natin lagi. That is, pag mag-perform tayo ng analysis, we don't really care what your system has or is before we start the analysis. Ang assumption natin lagi is that wala talagang nangyayari sa kanya. Okay? Kung meron mang nangyayari sa kanya, hindi na natin muna concern yun. Okay? So, magiging concern yun kapag nag-aral nga tayo ng mas advanced na techniques in control systems engineering. Okay? So, which in that case, napaka-useful ng Laplace transform because by the definition of the Laplace transform, it only obtains yung integral niyo for positive t. Okay, it only obtains the integral for positive t. So therefore, yung ating okay, I think I was disconnected for a while. So, I am not sure kung saan part ako na disconnect. Anyway, so as I was saying, yun nga yung we really don't we assume always that your system is idle or is relaxed, okay, or the initial state of your system is always zero, okay, kapag magagawa tayo ng analysis dito sa ating course. Okay? So, sa advanced courses na ng Control Systems Engineering na yun na, i-deal yung mga systems having initial conditions. Okay? Which, again, is an advantage of the Laplace transform in that manner. Dahil, yun nga, yung Laplace transform natin takes the integral for positive values of t. Or ito, dito lang mag-a-act in. Or dyan lang kukuha ng information yung Laplace transform ninyo. Okay? So therefore, consistent siya doon sa gusto nating mangyari kasi para sa atin, gray area ito. Actually, medyo inaccurate yung sinasabi ko kanina, wala tayong pakialam. Ang mas gusto ko pa lang sabihin is that ang assumption natin ay walang nangyayari sa system niyo during this part of the time. Okay, yun yung mas accurate na dapat na sinasabi ko pala. Okay, so we will just have our analysis on this part of your time. Okay, dun sa positive time na kino-consider natin. Okay, now again, we will not study the Laplace transform as the integral. Okay, pero diretso tayo sa paggamit ng properties ng Laplace transform, and at the same time yung paggamit ng tinatawag nating Laplace transform pairs. Okay, so here in table 1, meron tayong 7 na Laplace transform pairs. Okay, starting with the impulse function delta t. So we call this as the impulse function. Okay, then we have the step function u of t. Okay, then we have t times u of t. It's actually a ramp function. Okay, then we have the polynomial function t raised to n u of t, the exponential function e raised to negative at u of t, and these two sinusoids. Okay, so yung mga signals na yan, these are actually important signals in the analysis and design of your control system kasi more often than not, yung signals na gagamitin natin would fall in any of these 7. Although, hindi natin masyadong gagamitin itong impulse function in our case. Okay? Also, lahat kasi ng signals nyo from 2 to 7, lahat ng mga gagamitin natin most of the time are written in terms or as a product of the function and the step function. Okay? So, yun. Again, as I was saying before, whenever you multiply a function, okay, with the unit step function, okay, the product becomes f of t, okay, for positive t. Wala natin lagay yan dito. Mukhang hindi kita. Sa kabila natin lagay. Okay. So, ayan. So, whenever we multiply f of t with u of t, okay, the product becomes f of t, okay, whenever t is positive, and it becomes 0 when t is negative. Okay? But since again, ang pag-uusapan natin lagi is, yun nga, itong part lang na to ng timeline ninyo. That is when positive t. Okay? We may, dahil nga ito lang yung pinag-uusapan natin, we may actually drop the part of always writing your signals as a product of the function and the unit step function. Okay? We may drop the practice of writing signals as product of a function and a unit step function. Okay. At bakit natin siya pwedeng i-drop? Since our analysis and our analysis would only consider positive time. Okay? The analysis would always consider positive time. Okay? Or what is happening or what is the behavior of your system at positive time. Okay? And in that case, yung u of t nyo kasi equals 1. Kapag pag positive yung time. Okay? So, pag positive yung time niyo, yung u of t niyo is equal to 1. So, therefore, yung product f of t niyo, okay, instead of writing product f of t, u of t niyo, pwede na natin siyang ilagay as simply f of t. Okay? Since kung ito naman yung i-consider natin, yung positive time natin, then u of t is 1, So ito, pwede natin palitan to ng 1. Okay? So we simply, ano yun? May narinig ako sa aking teams. So we simply write, okay? We simply write yung ano natin, yung function natin as f of t na lang. So ganoon din dito sa table na to. Okay? Instead of actually writing everything in terms of u of t. Okay? Pwede niyong i-gawing 1. Okay? For example, itong u of t na to, instead of having it as u of t, you can say that that is 1 only. Okay? Still, it is a step function, pero since we are considering the behavior of your system for positive time. And for positive time, the value of your step function is 1. So, consistent naman siya sa definition ng step function. Okay? And another term that we can use for this function is a constant function. Kasi constant siyang 1 eh. All throughout the positive time, 1 lang yung value niya. So, therefore, it's a constant function. Okay? Ito, pwede nyo isulat na lang as t. This one is t raised to n. Ito ay e raised to negative 80. Okay? This is sine omega t. And this is cosine omega t. Okay? So, yun. I hope everyone would understand yung gusto nating i-point out dito. Okay? So, instead of actually always writing your function in terms of the product of a function and u of t, meron tayong ngayong motivation to not or to drop such practice. Okay? So, since yun nga, kino-consider lang naman natin yung analysis natin when the time is positive. So, we can actually rewrite your function in this manner. Okay? So, that is table 1. Sa table 1 tayo lagi magre-refer ng Laplace transform pairs. So, every time na maghahanap tayo ng Laplace transform, okay, magre-refer tayo ngayon lagi dito. Okay? So, ayan. Nilagay yung constant function. Constant function. This is an exponential function. And sinusoids. Yan. Okay, kasi mamaya kailangan itong table sa example. Now, let's look at table 2. Okay, table 2 lists the Laplace transform properties. Okay, so again, itong mga bagay na to, naaral niyo to sa advanced engineering mathematics course niyo. Okay? So dito sinasummarize lang natin siya at hindi na natin siya i-discuss isa-isa, okay? Since familiar naman kayo with them already. Okay? So gagawin lang natin is para ma-reinforce natin yung alam natin sa kanya. Okay? Is we will refer to this table while we are working on the examples. Okay? So, speaking of examples, let us have example 1, okay, which asks us to find the Laplace transform of this function. So, e raised to negative 80 cosine omega t plus theta. Okay. So, pero bago yan, let me obtain a i-screenshot natin tong table na to. Yan, para magamit natin siya doon sa baba. Yan. Okay, so lagay natin siya dito ngayon. Okay. So, first thing that you have to, so ito yung given, this is the given function. Okay. So, we are asked to find the Laplace transform of that given function. Now, you have to take note first that in this given function, all literals, when you say literals, yung mga letters na ginagamit dyan that does not pertain to any function. Okay. So, all literals there, but t are constants. Ibig sabihin, lahat ng letters na makikita nyo dyan, constants, maliban lang sa t. So, that means yung A, constant, yung omega, constant, yung theta, constant. Okay, yung E is not a literal. Yung E na to, baka sabihin nyo, yung E is not a literal. Okay, it is a function actually. It's actually a number. In this case pala, ang usage ng E dito is a number. It's the number E. Okay, so hindi siya literal. Okay. So, 'yun. So therefore, itong A, itong omega, tsaka itong theta are all literals and are considered constants. So ang variable lang natin dito is t. Okay, so ayun. Now, second, ang kailangan yung pansinin is that, okay, ang kailangan nyo mapansin ngayon dito is that the given function is not among those given on table 1. So yung mismong function na yan is not here. Okay? Meron kayong e raised to negative 80 dyan. Meron kayong cosine, dyan, pero meron kayong cosine dito. Pero yung form na nandito mismo, wala dun sa table ninyo. Okay? For example, this is cosine omega t. Okay? Pero yung nasa given ninyo kasi is cosine omega t plus theta. So, magkaibang form yan. Okay? So, they are different. These are different forms. So, while both of them are cosine function, iba yung form ng bawat isa. Okay? So, therefore, ang conclusion, wala sa table 1 yung function natin. So, anong gagawin natin kapag ganun? Okay? We will have to rewrite f of t into a form that is identical. Okay? That is identical to any of those given in table 1. Okay? So, yun yung goal natin ngayon. Kapag yung function ninyo kapag yung function na pinapahanap sa inyo yung Laplace transform, hindi nyo makita yung eksaktong form dun sa table 1, okay, you have to rewrite that function so that you would have to be able to transform or to re-express that function in terms of any function that is here in table 1. So, paano natin siya gagawin in this case? Okay? Itong function na to. Yan. Pwede natin itong gamitan ng trigonometric identity. Okay, pwede natin gamitan ng trigonometric identity yan. Okay, so anong trigonometric identity yung pwede nyo gamitin dyan? Verify nyo na lang to, no? Hindi na akong papakita ng source, pero ang trigonometric identity that applies to that is yung sum of angles natin. So, meron tayong sum of angles para sa cosine, para sa sine, para sa tangent, and so on. Pero in particular, ito yung identity na gagamitin natin in this case, which is equal to, again, verify na lang ninyo ito with your with other sources. This is cosine of A, cosine of B, minus sine of A, sine of B. Okay? So, ayan. Ngayon, in this case kasi, yung A natin dito is yung omega t ninyo. Tapos yung B natin is yung theta. Okay? So, therefore, pag nire-write natin ngayon ito as cosine omega t plus theta, okay, ito magiging cosine omega t cosine theta minus sine omega t sine theta. So, that is why, okay, including ngayon ito, yan, yung exponential na yan, we can now translate this entire function into this. Okay? So, yan. Now, ngayon, take note na wala pa rin kayong wala pa rin kayong eksaktong, actually ito kasi constant na to. Okay, tsaka to. Those are constants already. Yung cosine theta tsaka yung sine theta. Kasi again, we consider theta to be a constant number. So therefore, cosine theta is a constant, sine theta is a constant. And wala pa rin kayong eksaktong form para sa e raised to negative 80 cosine omega t tsaka e raised to negative 80 sine omega t. Okay? But kung titingnan niyo yung kung titingnan natin yung table 2. Okay? Kung titingnan niyo yung table 2. Meron kayo ditong ito, yung property 4. Okay? Which is called the frequency shift theorem. Okay? So, makikita niyo dito sa property 4 na kinukuha niya dito yung Laplace transform ng product ng e raised to negative 80, okay, times a function. So, in the case na hinahanap natin kanina, okay, that may be teka lang, iyan natin to. I-screenshot natin to. Ito, 3, 4, 5. Kasi yun yung kailangan na, 2, 3, 4 pala ang kailangan natin. Yan. So, okay. So, as I was saying, dahil nga dito, hindi pa rin makikita yung e raised to negative 80 cosine omega t, cosine theta dun sa niyo, sa table niyo. Okay. Pero ito na yung part na pwede natin siyang gamitan ng identity ng properties. Okay. So, unang-una, pwede niyo siyang gamitan ng linearity. Okay? You can use linearity. Linearity in order to actually dalawang linearity kasi yan. Yung ito, this is linearity in terms of scaling. Okay? Or multiplication of a constant. Kasi this means na kapag yung function niyo is multiplied by a constant, okay? It just means na pwede niyo kunin yung Laplace transform nung f niyo. Okay? And multiply the Laplace transform with the constant. So ito yung tawag yung ilalabas niyo yung constant usually. Okay? So this is the property for scaling of a constant. Yan. Ito naman is yung property of addition of functions. So kung meron kayong dalawang functions na nakasum, okay, tapos kinukuha niyo yung kanyang Laplace transform, then that's the same as simply getting the sum of the respective Laplace transforms of your function. So this is the linearity property for sum of functions. Yan. So dito, obviously, makikita nyo dito na meron kayong dalawang function. Ito. Okay, tsaka ito. Okay. So yun nga, meron kayong function na ito. Tsaka ito. So parang yan yung F1 ninyo. Ito yung F2 nito. Okay. And kung kukunin nyo yung Laplace transform niya, gagamitan niyo yan ng property wherein you can take the Laplace transform of each function. So that ang ending yung magiging niyo is yung sum of the Laplace transform of each. So kunin niyo yung Laplace transform ng unang term, tapos kunin niyo yung Laplace transform ng pangalawang term. So dito ginamitan natin siya ng linearity. Linearity number 3, which talks about sum of functions. Okay? Now next, dun sa kukunan nyo ng Laplace transform, itong cosine theta, this cosine theta here, yan, tsaka itong sine theta na to, those are constants. Kasi nga sinabi na natin kanina na yung theta is a constant, therefore cosine theta is a constant. Sine theta is a constant. Okay, so this is now K, say K1, and this is K2. Okay, and again, by the linearity theorem on scaling of a constant, pwede nyo ilabas yung constant na yun. So that, dito sa second statement natin, itong constant na to, ayun, ilalabas natin siya dun sa Laplace form. Kaya eto na siya ngayon. Ito, tsaka ito. So that's how we apply yung linearity ng scaling of a constant. Okay? Now, we now go to the part na kailangan natin ngayon yung Laplace form nito. Yan at saka yan. Okay? The problem is, wala pa rin yan sa table 1 ninyo. Pero as I was saying kanina, makikita nyo yung sa properties, ito. Wherein meron kayong f of t na naka-scale o naka-multiply with an exponential function. Okay? So, sabi ni Laplace, ng properties ng Laplace form, pag meron kayong function na naka-multiply ng exponential, okay, pwede nyo siyang gamitan ng frequency shift theorem. Okay? Ano yung frequency shift theorem? Pag kinukuha nyo yung Laplace form ng product na to, that is an exponential multiplied to a function, what you would do is get f of s. Okay? Kunin natin yung f of s. Kunin natin yung Laplace form ng function lang na to. Okay? Tapos, dun sa f of s, okay? Dun sa f of s, we have to replace s with s plus a. Okay? You replace s with s plus a. So, pag nakuha nyo na yung f of s, yung s ngayon dun sa f of s na nakuha ninyo, papalitan natin siya ng s plus a. Okay? Plus a, kasi negative a ito. Take note, take note ha. Negative a yon, plus a yung ipapalit natin. S plus a yung ipapalit natin. So ngayon, pag napalitan nyo na yung s with s plus a, ito na yon, yung f of s plus a. And again, ibig sabihin kasi nun, kaya siya naging frequency shift because s is actually in a variable in what we call in frequency domain. Although this is not exactly the frequency domain that technically it is. Okay, pero more or less, we can consider S to be in frequency domain. Okay? So, ayun. So, since yung S, yung frequency domain variable niyo, dadagdagan nyo ng constant. That's called shifting. Kaya that is why, tawag sa theorem na to is frequency shifting. Okay? So, yun na nga. That's property number 4. So, we can evaluate the Laplace transform of e raised to negative at cosine omega t. Okay, using the frequency shift theorem. Okay, of table 2, item number 4. Ito yung tinuturo ko. Oh. Ay, mali. Yun pala. Yun. Okay. So, anong gagawin natin dito? Ito kasi yung f of t ninyo. That's your f of t. So, again, pag i-apply natin yung if we are to apply the frequency shift theorem, okay, gagawin natin, kukunin natin yung f of s niyan, yung Laplace transform ng cosine omega t. Okay? So, yung Laplace transform ng cosine omega t ay nasa table 1. Yun yung good news ngayon doon. Ayun. Ito. Nasa table 1 na siya. Okay? So, yan yung ito ngayon yung magiging f of s natin. Okay? So, ayun nga, sabi nga doon, yung cosine omega t ninyo is ito. Yung magiging f of s natin according to table 1. Number 7. Okay, so magiging s over s square plus omega square yan. Tapos, anong susunod na gagawin? Yun nga, replace s with s plus a. Okay, so ang next na gagawin nyo dyan is to replace s with s plus a. As in, papalitan nyo siya talaga ng s plus a. Okay? So, since we take note na negative a siya dito, okay, negative a siya dito. So, ang ipapalit talaga natin is s plus a talaga. Okay? So, ayun. Ngayon, kapag ito ngayon, pinalitan nyo yung S at saka ng S plus A, itong mga S na to, with S plus A, ito na yung lalabas sa kanya ngayon. Magiging S plus A over S plus A squared plus omega squared na siya. So, yun na yung Laplace transform ngayon nung first term niya. Ito, yung Laplace transform nito. Magiging, ano na to, S plus A over S plus A squared plus omega squared. Okay? Then, in the same manner, pwede nyo siyang gawin dito. Okay? So, again, itong part na to, okay, under siya nung property 4, okay, yung frequency shift, okay. So, sa frequency shift, simulan natin siya with taking the Laplace transform of sine omega t. Ito, Laplace of e raised to negative at sine omega t. We start with ito. Kunin natin yung kanyang Laplace transform, which according to table 1, number 6 ito. Yun, table 1, number 6, ito siya. Tapos omega over S square plus omega square. So, ano daw siya? Omega over S square plus omega square. Then, yung S nito, papalitan natin ng S plus A. So, magiging ano siya? Omega over S plus A square plus omega square. So, yun. Papalitan talaga natin siya. Again, S plus A yung ipapalit ko dito kasi nakita natin na negative A ito. So, S plus A yung ipapalit ko doon. So, ang magiging transform ngayon ito, okay, is ito na nga. So, ito na yun. Makikita niyo dito. Okay? So ngayon, pagsamahin natin ngayon yung nakuha natin dun sa naiwan natin before kasi ito yung iniwanan nating expression. At bago natin kinuha separately, bago natin in-evaluate separately ito, okay, tsaka ito, nakuha na natin yan pareho. So we will have to replace that with what we have obtained. Magiging ganito na siya. So ito na yung cosine, tapos ito na yung nakuha natin para sa e raised to negative at, cosine omega t. Ito na yung nakuha natin para sa e raised to negative at sine omega t. Okay? Now, always that when you get the Laplace transform of something, you need to write, okay, you need to write that function as one rational term. Okay? Yan yung rule natin lagi. Pag kumuha kayo ng Laplace transform, ng isang function, ang Laplace transform na isusulat ninyo dapat laging rational term. One rational term lang siya. So, which means isi-simplify natin ito. Okay, isi-simplify natin itong entire thing na to into one rational function. So, i-LCD natin siya. So, the least common denominator of these two functions is ito naman na. Okay, pareho naman siya denominator eh. Okay, so we can simply just have this as S plus A times cosine theta minus omega times sine theta. Okay, and then i-expand natin ito. Okay, para maging S cosine theta, okay, plus A cosine theta minus omega sine theta. And take note na ito, lahat yan constant. Kasi A is a constant, theta is a constant, omega is a constant, and of course, theta is a constant. So therefore, yung mga pinarenthesis ko dito, lahat yan constant yan. So parang naka-polynomial form ngayon itong ano nyo. Naka-polynomial form itong numerator niyo. AS plus B. Okay, constant, ito, cosine theta times S plus B. Isang constant. Okay. So, yan yung gusto nating mangyari dun sa natin, sa function natin, no? Sa Laplace transform natin. Dapat ano siya? Numerator polynomial over denominator polynomial. Ganyan dapat nakasulat lagi yung Laplace transform natin. Okay? So, ayun. Okay. Magpapa-excuse lang ulit ako sandali. Okay. Saglit lang. Okay. Now, let's proceed with example 2. Okay. Which asks us to find the inverse Laplace transform of this function. Okay. So, pag naman inverse Laplace transform yung problem natin. Dito kasi dito sa problem 1, find the Laplace transform of meron tayong f of t na given. Gagawin natin siyang f of s. Okay? Take note, hindi equal sign yung ginagamit ko, arrow. Because this is a transform. So we don't really have the notion that f of t is equal to f of s. Actually, that's not true. F of t is not equal to f of s. Okay? Ang transform operation kasi is more of remapping. Okay? This is more of a remapping process. Okay? Not rewriting your function in another form. Okay? So, kaya arrow yung ginamit ko, hindi equal sign. Okay? So, whenever you have a problem of Laplace transform, or whenever you're asked to find the Laplace transform of a function in f, or a function f of t, okay? Ganito yung proseso natin. From f of t, gagawin natin siyang f of s. Okay? Dito naman, sa inverse Laplace transform, okay? In the problem of inverse Laplace transform, bibigyan naman tayo ng f of s, okay? We will have to transform it back to f of t. Okay? So, yun yung natin. Gagawin natin sa example 2. Okay? So, yun nga, given tayo ng f of s, gagawin natin siyang f of t. Or yung sagot natin, magiging f of t, essentially. Okay? Gandaan natin. Yan. Okay. Now, pag inverse Laplace transform yung problem natin, the first thing that you have to observe is the denominator. Okay? So, ano bang meron sa denominator nung Laplace transform nyo? Unang-una, kung mapapansin nyo yung nasa table 1, lahat yan, rational function. Okay? Lahat yan rational function. So, dalawa lang naman yung pinalalaglagan yan. Okay? It's either quadratic siya, okay, o kaya linear. Katulad nito, tsaka nito. So, o kaya, pwede rin kasi siyang polynomial, katulad nito. Okay? Pwede siyang polynomial. Okay? Ito, tsaka to, polynomial yan. Okay? So, pwede siyang quadratic. Okay? And sometimes, pwede siyang buong quadratic. Like, for example, meron kang s square plus as plus b. So, buong quadratic talaga yan. Okay? So, yan yung mga possible na denominator na makikita nyo doon sa Laplace transform niyo. Okay, so in this case, kung papansinin nyo mabuti, lahat yan nakalinear. S, S plus 2, at saka S plus 3. Pero itong S plus 3, may square. So, it indicates, okay, dahil may square yan, it indicates that this one is what we call a repeated factor. Okay? Kasi nga, may square siya eh. So, lalabas dyan, ano yan? S plus 3 times S plus 3. Kaya siya repeated factor. Okay? So, in our case, okay, in our case, we can, if that is, kung ganyan yung itsura ng denominator ng f of s ninyo, ang pwede nyo gawin dyan sa simula is to actually perform a partial fraction decomposition. Okay? Kapag yung denominator ninyo is hindi siya nag-iisang linear, okay, o kaya nag-iisang quadratic na denominator. Kumbaga, sa denominator niya, halo-halo naka-factor yung linear at saka quadratic factors, okay? Then kailangan niyo mag-perform ng partial fraction. Sorry. Yan. Ng partial fraction decomposition. So I hope alam niyo pa 'to galing sa algebra ninyo. Okay? So yung partial fraction decomposition nitong particular function na to is a over s, okay, plus b over s squared. So isang term para dun sa dito. Okay, para dito. Another term para dito sa denominator na to. And two terms. Ayan, two terms para dito sa repeated factor na to. Okay? So, again, pansinin niyo yung pagkaka-setup. Okay? Pansinin mabuti yung pagkaka-setup ng dalawang terms na yun. Okay? And then, ang task natin ngayon is to evaluate this, coefficients. Itong A, itong B, itong C, at saka itong D. So, we have to evaluate those. Okay? So, how do we evaluate them? Yung coefficients A, B, at saka D, okay, can be easily evaluated using yung tinatawag na cover-up method. Wait lang. Maglagay nga tayo ng highlighter na isa pa. Ito black. Tabi natin siya dito. Okay. So, parang cover-up method. Paano yung cover-up method? Yung cover-up method is that, kung halimbawa ina-evaluate nyo yung A, tignan nyo yung denominator ng A dun sa expansion. Okay? So, since ang denominator ng A dun sa expansion is S, tatanggalin nyo itong S dito sa tatanggalin nyo yung S dun sa dun sa ina-expand niyo. Yung the rest, yun yung gagamitin nyo to evaluate A. But you have to evaluate A when S equals 0. Saan nakuha yung S equals 0? Yun yung root nito. Yun yung root nung denominator nung term na to. So yung root is obtained by equating the denominator to 0. So since S lang naman to, pag in-evaluate nyo pag kinuha nyo yung root niyan, you have to equate S to 0. So therefore, yun nga yung S equals 0. So substituting now S dito, 0 dito sa S na yan. Okay? That should give you 10 over 2 times 9, so 5 over 9. Okay? So that's for A. Paano yung B? Okay. Again, balikan nyo to. Tingnan yung denominator ng B dito. Okay? So, yung B is S plus 2, yung denominator niya. So, gagawin natin, tatakpan natin yung S plus 2 dito. Okay? Tapos, yung matitira, yung 10 over S times S plus 3. Yan yung gagamitin natin. 10 over S times S plus 3 squared. Yan yung gagamitin natin. But we have to evaluate that when S is equals negative 2. Okay? Again, tignan nyo itong denominator niya. Okay? S plus 2. I-equate natin siya sa 0. So that becomes S equals negative 2. Kaya siya negative 2 here. Okay? So, ayun. And finally, yung D, ganun din. Okay? So, yung D dito is S plus 3 squared. Hindi ko kagad ma-evaluate yung, yung C kasi S plus 3. Hindi ko mako-cover up lahat itong S plus 3 dito. Kasi S plus 3 yung denominator to, kailangan isang S plus 3 lang din yung i-cover up ko. Okay? So, therefore, mahirapan akong gawin yun dahil kailangan dalawa eh. May isa pang may iwan. So, hindi pwede. Okay? Kaya dito muna ako sa D. Kasi yung D, may S plus 3, S plus 3 square ko, patatakpan ko siya ng buo. Okay? So, again, yun nga yung gagawin natin. Okay? Then we will have to cover up yung S plus 3 dito. Nipisan natin ng konti. Ayan. Ayan. Yung S plus 3 dyan, tatakpan ko ng buo. S plus 3 squared pala. Ayan. So, ang may iwan dyan is 10 over S times S plus 2. Okay? Which you evaluate for S equals negative 3. Again, ito, i-equate nyo sa 0. Yung S plus 3 squared, i-equate nyo sa 0, then solve for S. So, para makuha nyo yung root niya. So, doing that, you'll have 10 over, yung S is negative 3. Tapos, yung negative 3 plus 2 is negative 1. So, 10 over 3. Okay? So, meron tayong ngayong A, B, at saka D. Okay? Ang problema natin, C. Okay? The coefficient C is found by evaluating the derivative. So, kung ano yung nakuha nyo ngayon, ang gagawin natin ngayon sa C is ganito. Pwede rin takpan ng buo yung S plus 3 squared. Nasa C ako Tapos yung may iwan, yung 10 over S plus 2. Okay? Kukunin ko yung derivative niyan. Okay? I'll get a derivative of that. And then, at saka ako isa-substitute yung root nung S plus 3. Okay? Ulit para sa C, okay, cover natin yung S plus 3 squared ng buo. So, ang may iwan dyan is 10 over S times S plus 2. Tapos, ang sunod dyan is get the derivative of nito, 10 over S times S plus 2. Okay, and then, pag nakuha nyo na yung derivative at saka nyo isa-substitute, yung root of S plus 3, which is yun nga, S equals negative 3. After nyo makuha yung derivative. Okay, ang maganda dito, kung may calculator kayo na na 991, pwede nyo siyang idiretso sa sa calculator. Okay, so wait lang, buksan ko lang yung calculator ko. So, eto siya. Okay. So, again, pagka-cover natin yung S plus 3 squared, ang may iwan doon is 10 over S times S plus 2. Okay? Tapos kukuha natin yung derivative nun. Pwede natin siyang gawin dito by using this function, yung derivative na function na yan. Okay? So, that is 10 over x times x plus 2. Tapos, ito, yung ilalagay natin dito, yung isa-substitute natin, which is, in this case, negative 3. So, ilalagay natin negative 3. So, press equal. Yun yung may iwan. Yung 4.444 na yan, pag kinonvert nyo sa decimal, that would be 40 over 9. Okay? So, ayun. So, yun yung procedure kapag hindi nyo matakpan lahat nung factor. Okay, kapag repeated siya. Okay? So, ayun. Now, since nakuha natin siyang 4, 5 over 9, negative 5 over 9, 10 over 3, at saka 40 over 9, then we will have the following partial fraction expansion para dun sa given function ninyo. Okay? So, meron tayong partial fraction expansion. Okay. Ngayon, for us to be able to get yung inverse nito, okay, yun na nga, we have first to apply yung linearity. Okay? Dahil ito ay sum ng mga f of s's, ng mga Laplace transforms, then yung original function yan, yung original na pinanggalingan ng function yan, is also sums of different functions, na ito yung mga Laplace transforms. So therefore, para makuha natin yung Laplace transform nito, yung inverse Laplace transform nito, yan, para makuha natin yung inverse Laplace transform niyan, then isa-isahin natin yung pagkuha ng inverse Laplace transform nitong mga terms na to. Yan. Isa-isahin natin yung pagkuha ng inverse Laplace transform niyan. So ito na nga yun. Okay? Tapos, since may mga constants kayong nakikita dyan, ito, constant yan, constant ito, at saka yan. Again, by linearity, okay? Yeah, by linearity, table 2, item 2. Okay, pwede nyong ilabas yung constant na yan. So, lalabas nga dyan itong 5/9. Okay, lalabas yung 5/9. Itong -5. Itong 10/3. Tsaka itong 40/9. So, ito na yung ang may iwan na lang ngayon sa Laplace transform niyo. Ito. Yan. Yun yung mga i-evaluate natin. Ngayon. Balikan natin yung table nyo, no? Punin natin ulit yung copy ng table nyo. Yung nandito na lang pala kasi... Ano, sige. Ito na lang. Aha. Napasok na ba siya dito? Yan. Kahit maliit yan, makikita nyo yan. Clearly, itong unang term niyo na 1/s, yan. Ito yan. Itong number 2. Okay? So, dapat pala iba-iba yung ginamit nating kulay sa pambilog sa kanya. Yan. Nating orange to. Ito, orange na rin to. Tapos ito, purple. Ay, di, purple pala yung una. Ano lang. Uy, rainbow pala to. Okay, so, ayun. Itong unang term niyo, okay? Kita niyo yan dito. Yan, kita niyo yan dyan. Actually, yun siya mismo. 1/s siya mismo. So, nakalagay dito, kung 1/s yung f of s mo, ang f of t mo para doon ay 1. So, therefore, ito, equivalently, magiging 1 na lang yan. So, itong dalawang to, okay, yan dalawang yan. Makikita nyo yan dyan, ito siya, yung number 5. Magkaiba lang yung a niya. Dito, yung a niya is plus 2. Ito naman, plus 3. Pero pareho yung magiging e raised to negative 80. Yun nga lang ito, since dito ay 2 ito, this becomes e raised to negative 2t. Okay? Ito naman, itong isang to, okay? Since ito ay s plus 3, ang magiging inverse niyan is e raised to negative 3t. Okay? So, nakukumpleto natin yung yung mga inverse Laplace transform nito ngayon. Okay? Isa na lang. Itong part na lang na to. Okay? So, yung pang-apat, wala yan sa table. Okay? Wala yan sa table natin. Okay? Makita nyo, wala diyang katulad nung ano. Okay? Pero, may makikita kayo dyan na naka-square itong S. Tapos so naka-plus. Pwede nyo i-treat yan muna as ano, S square. Na yung S, pinalitan ng S plus 3. Nakakatuwa naman tong pen na to. Para siyang S square na yung S pinalitan ng S plus 3. At kung maaalala nyo dun sa first example natin, ginagawa natin ito in the context of frequency shift theorem. Yung property, okay, sa table 2, item 4. Yan. So, pagka ganun, ang gagawin natin is, magsisimula muna tayo dun sa inverse ng S square. Or ng 1 over S square. Okay? Magsisimula muna tayo dun sa property ng 1 over S square. Okay? Ano yung inverse ng 1 over S square? Okay? So, dito, ang inverse ng 1 over S square, so bali ito yun. Yan. Ang inverse ng 1 over S square ay T. Okay? So, magiging T pala yan. So, magiging T. But, dahil nga merong ganitong operation, at i-apply natin si frequency shift theorem. Okay? Dun sa frequency shift theorem ninyo, i-require niya na i-multiply nyo to by an exponential. Okay? Which is e raised to negative 3t. Balikan natin yung frequency shift theorem na yun. Ito. So, kung yung f of s ay papalitan nyo daw ng s plus a. Kung magsisimula kayo sa 1 over s square at yung s ay papalitan nyo ng s plus 3 para maging ano siya, 1 over s plus 3 square siya. Okay? Again, magsisimula tayo dun sa inverse nito. Sa f of t nito. Which yun na nga, nakita sa table 1 na siya ay t. Pero dahil sa ginawa natin to, so ito yun, i-require niya tayo na yung f of t natin nakamultiply nung ito. Okay? Yung f of t natin, yan, nakamultiply nito. Nung e raised to negative at. But in this case, yung a na yon is ito. Yung plus 3 dyan. So, which means ito, minus 3 ito. So, kaya magiging ito, ang magiging inverse ngayon nito is t times e raised to negative 3t. Okay? So, I hope maliwanag yun. Yung part na yun. Okay? So, ayun, nakompleto natin ngayon yung inverse niya. So, this is 5 over 9 times 1. Ito yun. Sorry. So, yung 5 over 9 times 1, ito yun. Tapos, negative 5 times e raised to negative 2t. Yan. Tapos, 10 over 3 times e raised to negative 3t. And then, finally, 40 over 9 times t e raised to negative 3t. Okay? So, yan yung pagkuha ng inverse sa Laplace transform. Okay? So, ano naman tayo? Magbe-break lang muna ako ng mga 10 minutes lang. So, I'll be back by siguro mga 5:05. Okay? Para maka-refresh muna tayo. Okay? So, sige, I'll see you later, mga 10 minutes lang. Okay, good afternoon ulit. I hope I'm being heard. So let me continue, okay, with our discussion. So, Laplace's form can be used to solve constant coefficient linear differential equations using its differentiation property. Okay? So actually ito yung andito yung parang pinaka-power ng Laplace's form. Especially in the context of system modeling. Okay? So ano yung sinasabi dito na ano yung sinasabi ditong wait lang ayan. Ano yung sinasabi ditong table 2 items 7, 8, and 9. Okay, so kunin ko lang siya dun sa ayan. Ito siya. So kuha tayo ng clippings. Then lagyan tayo siya dito. Okay, so ito. Tingnan natin to, no? Dito pa natin. So ito yung tinatawag natin ito yung tinatawag nating differentiation property of the Laplace's form. Essentially, yung sinasabi dito is yung ano yung Laplace's form ng first derivative ng f, ng second derivative ng f, at saka ng nth derivative ng f. Okay, so yun yung andito. The Laplace's form of a derivative. Okay? So, dun sa number 7, yung Laplace's form of the first derivative. Ang sinasabi doon is that you get the Laplace's form of f nung small f dito, so magiging big F siya. Then, yung Laplace's form niya, multiply natin with s. Okay? And then, this result should be subtracted with this quantity called the initial value of f of t. Initial value of f of t natin yan. Okay? So, yun yung ibig sabihin doon. Yung f of t natin. Yung f of 0 na yan. Okay? Dito sa pangalawa, okay, yung Laplace's form ng second derivative ng small f, okay, requires us to get the Laplace's form of small f para maging big F siya. But since we have here second derivative, ang ipamumultiply natin sa kanya ngayon is yung square nung s. Okay? So hopefully napansin natin yan. Now, yung next term nito, since s square ito, ang susunod dyan is s. And then multiply natin siya again nung initial value nung f of t. So ito yun. And then minus itong dulo, okay, which is now the initial value of f prime of t. Ibig sabihin, kunin natin yung first derivative ng f of t, tapos kunin natin yung initial value niya by substituting 0 to t. Okay? So, yun yung pagkuha ng second derivative ng pagkuha ng Laplace's form ng second derivative ng function. Okay? Finally, sa nth derivative is again, kunin natin yung Laplace transform ng f niyo, small f niyo, para maging big F siya, para maging f of s siya. And then, i-multiply natin siya with n. Ng nth power ng s, dahil nth derivative siya. Okay, so yun, dun pa lang papansin nyo na yung pattern dito. Okay? And then, i-minus natin siya with, ito pag in-expand nyo to, essentially, magiging polynomial to na katulad ng pattern dito. Like for example, kung ang pinag-uusapan natin is Laplace transform, ilatag lang natin dito, no? So yung Laplace transform ng first derivative df over dt, okay, is s times f. Hindi ko nalagay yung f of s, minus f of 0, okay, yung Laplace transform ng second derivative ng f with respect to t, okay, is s squared times f, okay, minus s f of 0, okay, minus f prime of 0. Okay? So, dun tayo sa third derivative. Third derivative ng Laplace ng third derivative ng f with respect to t. So, s cube ito times f kasi third derivative na siya. Minus s square times f of 0. Okay? Minus s times f prime of 0. Okay? Minus f double prime of 0. Okay? So, pansinin niyo mabuti na dapat, unang-una, mag-uumpisa ito. Okay? Yung first term nito is yung Laplace transform ng original function niyo. Yung hindi naka-derivative, yung original yung nung small f niyo. Okay? And then i-multiply niyo siya with a power of s na yung power ay equivalent dun sa order ng derivative. So, ito dapat pareho ito. Yan, at saka yan. Yan, at saka yan. Ito, may 1 to eh. Yan. So, may 1 din ito actually. Yan, pare-pareho yan. Okay? So, dyan mag-uumpisa yan. Now, yung nandito, yung the rest of the terms here, okay, is a polynomial, okay, formed using initial conditions. As coefficients. So, ano yung mga initial conditions na yun? Again, yung initial conditions dito is yung f of 0 or yung value ng f of t when t is equal to 0. Okay, the value of f of t when t equals 0. F prime of 0 or the value of f prime of t when t equals 0. F double prime of 0, which is the value of f double prime of t when t equals 0, and so on. Yan yung tinatawag, ito mga to, tinatawag natin initial conditions. Okay? So yung part na to, actually itong part na to na yun. Okay, yung part na yan, okay, is a polynomial formed using initial conditions. So saan magsisimula yung polynomial ninyo? The polynomial would start with 1 degree less than the first term. Okay? So, kung s cube ito, magsisimula kayo sa s square. Okay? Tapos, tandaan nyo na ang dulong term lagi is a constant. Okay? The last term would be a constant. Okay? That is the value of the derivative 1 less than what is being transformed. Okay? Kung third derivative yung hinahanapan nyo ng Laplace transform, ang dulong term niyan ay second derivative. Kung ang hinahanapan nyo ng derivative ay ng Laplace transform ay second derivative. Okay? Ang dulong term niyan ay first derivative. And so on. Okay? So, kung i-expand pa natin yung isang beses para makuha natin yung pattern. So, yung Laplace transform, for example, ng fourth derivative ng f with respect to t. Again, this will start with s to the fourth times f. Okay? Minus, kung s to the fourth ito, susunod dyan is s cube times f of 0. Ang susunod dyan ay s square times f prime of 0. Sorry, f prime lang of 0. Minus s times f double prime of 0. Okay? And then, minus yung dulo, last term, is f triple prime of 0. Again, the last term, okay, the last term here, third derivative, is one order lower than the order of the derivative dun sa given. Okay? So, again, collectively, itong mga yung mga yan, collectively, ang tawag natin dyan ay mga initial conditions of your system. Okay? Of your function. Okay? Pero those are, initial conditions pertain to initial values at different derivatives. Okay? Ngayon, later on, dahil nga sa ang consideration natin dito sa ating course is that we will consider analyzing the analysis of your system with zero initial conditions. Mapapadali natin ito pag-a-apply ng differentiation property dahil lahat ito magzi-zero. Okay, kapag yung initial conditions natin is said to be, or if we consider the initial conditions to be zero, then lahat ng ito magzi-zero lahat siya. So ang may iwan lang essentially dun sa ating ay eto lang. Okay? So ayun. Now, let's take a look at the problem again. Let's try to solve this differential equation. Okay? Using Laplace transform and assuming all initial conditions are zero. Ayun, ito yung sinasabi natin. So assuming all initial conditions are zero. Okay? So, una, kapag magsosolve tayo ng differential equation na katulad niyan, sulat ko mo dito. Plus 12 dy over dt plus 32y equals 32 u of t. Lagyan natin u of t muna. Okay? The first thing that you have to do para ma-solve nito is to actually apply yung Laplace transform sa entire equation. Okay? But the thing is that, since, so kung i-apply natin yung Laplace transform sa entire equation, so we'll apply it on the left side. Okay? And then we'll apply it on the right side also. Okay? And then, by linearity, okay? By linearity, okay? Makikita natin na, kasi nga, i-apply natin siya sa sum of different functions. Okay? So, therefore, pwede nating i-distribute yung operation. So, that is, pwede nating isulat yung operation as the Laplace of the second derivative of y with respect to t plus the Laplace of, or naka-12 to, no? So, ilalabas ko muna yung 12. Tapos, kukunin ko yung Laplace transform ng first derivative ng y with respect to t. Okay, tapos ito, may 32 ito. So, ilalabas natin yung 32. Then, kukunin natin yung Laplace transform ng y, which now equals the Laplace transform of 32 u of t. Okay? So, that's how we apply yung linearity. Okay? Ngayon, applying din, kasi ito na yun eh. Lalabas, ito na yan. Yung first operation natin, ito. So, ito yun. Okay? Tapos, ito. Ito yun. Okay? Then, ito. Ito yun. And then, finally, ito. This one. Is this one. Okay? So, in these cases, i-apply natin ngayon yung differentiation property. Wait lang. Ayan. Nawala sa connection nito. Ayan. So, applying now differentiation property. Okay? So, again, we're finding the Laplace transform of the second derivative. Okay? So, again, dun sa natutunan natin dun sa this is s squared times y. Okay? Then, a polynomial using the initial condition. So, kung s squared, susunod dyan s, y of 0, and then y prime of 0. Again, ito yung dulong term. Since this is second derivative, dapat ang dulong term niyan ay first derivative. Okay? So, dito naman, nilabas natin yung 12 muna dito. Then, we get the Laplace transform of dy over dt. Okay? So, that would be sy. Okay? That would be sy. Okay? Ito lang muna. at mali pa rin nakalagay dito. This is 12 at sy minus y of 0. Dapat may parenthesis to. Okay, so i-correct natin yun. May parenthesis dapat siya. Kasi 12 ilalabas muna natin eh. Tapos yung derivative, yung Laplace ngayon ng first derivative is ito lang. Okay? Then dito, ilalabas natin yung 32. Tapos kung yung Laplace transform ng y. Ang Laplace transform ng small y ay big Y. So, ano yun? Laplace transform ng y of t is y of s. Okay, with y now, yung y of s is now an uppercase y. So, ito na nga yun. Then yung Laplace transform ng right side ninyo, which is 32u of t, from table 1. Okay? Ang nakalagay lang kasi doon is u of t. So, ang Laplace transform niyan is 1 over s. So, kung may 32 yan, kung may 32 yan na constant, okay, kung may 32 yan na constant, ilalabas natin yung 32, kukunin natin yung Laplace transform nito. Okay. So, ito, mamumultiply ngayon ito with 32. Kaya magiging 32 over s. Now, since the problem states, okay, the problem states that the initial conditions are 0. So, yung initial conditions na tinutukoy dito are all initial values of y and its derivatives. So, ibig sabihin, ito yon. Yan, yan, at saka yan. Lahat daw ng value niyan ay 0. Okay? Lahat daw ng value niyan ay 0. So, ano ngayon ang may iwan kung lahat ng value na yan ay 0? Ang may iwan na lang dyan ay ito, s. S square y, yun na lang may iwan dyan. 12sy, 32y, at saka ito. So, ibig sabihin na magiging Laplace transform ngayon nito ay simply s square y na lang. Okay? Plus ito ay 12 sy. Okay? Ito, ang magiging Laplace transform niyan ay 32y na lang. And then ito, magiging 32 over s. Yan na lang yung may iwan dyan. Dahil nga itong tatlong terms na to, all of them are 0 because our initial conditions are 0. So, ito na yung magiging resulting equation natin after taking the Laplace transform. Now, what we want to do here is to solve for y. Ang gagawin natin dyan is to solve for the uppercase y. Essentially, yung y dito, it also means y over s. Y of s pala. Okay? Y lang muna yung sinusulat ko para hindi masyadong makagulo yung of s natin. Okay? So, ayan. Now, so solving that for y, okay, which means kailangan kong i-factor out ito for y. So, ipa-factor out ko yung y dito. Ang may iwan sa mga factors would be s squared plus 12s plus 32. Okay? And then, i-divide ko both sides with this denominator. Okay? I-divide natin siya both sides with this denominator. Para ang maiwan sa right side, sa left side, is yung y or y of s na nga lang. So, ngayon, sa kabilang side, ito na yung magiging result. Okay? Yan na yung magiging result ngayon. Now, we take note that this quadratic factor, yung quadratic factor na yan, is factorable. Kaya natin siyang i-factor into s plus 4 at saka s plus 8. Verify that. Algebra na lang naman yun, no? So, paki-verify na yung s square plus 32s, plus 12s plus 32 factors to s plus 4 times s plus 8. So, kaya, ang mangyayari ngayon is itong denominator ninyo. Okay? Instead na isang linear at isang quadratic factor, meron na siyang tatlong linear factors. Which now translates, dahil nga ganito yung denominator ninyo, okay? At na-factor natin siya into linear factors, kailangan natin pag-iwahiwalay natin yung mga linear factors na yan into rational terms. Okay? So, gagawa tayo ngayon ng partial fraction decomposition. Okay? So, ngayon, dahil naka-partial fraction decomposition na siya, we need now to solve for A, B, and C. So, in example 2, na-demonstrate na natin kung paano yung cover-up method. Okay? So, again, kung S ito, we will cover up S here. Okay? We will cover up S here. So, yung may iwan, yung 32 over S plus 4 times S plus 8, i-evaluate natin with S equal to the root of S, which is 0. So, upon evaluation, we will determine that to be 1. Okay? For B naman, ito yung i-cover natin kasi yan yung denominator ng B dito. So, yung may iwan dyan is 32 over S times S plus 8. At i-evaluate natin yan when S is negative 4. S is negative 4 dahil yun yung root ng S plus 4 here. Okay? So, evaluating, this becomes 32 over negative 4 times 4 or negative 32 over negative 16. So, that should give you negative 2. Okay? And then finally, para ma-solve natin yung C, S plus 8 yung denominator niya dito. So, i-cover natin yung S plus 8 dyan. So, may iwan is 32 over S times S plus 4. And i-evaluate natin ito when S equals negative 8. Negative 8 being the root of this denominator. So, doing that, we will have 32 over negative 8 times negative 4 or 32 over positive 32. So, that gives us positive 1. So, ngayon, if A is 1, B is negative 2, and C is 1, magiging ano siya, 1 over S minus 2 over S plus 4, okay, plus 1 over S plus 8. Okay? So, ito na nga yun. Okay. Now, yung first term, ay makikita niyo sa table 1. Yan yung kung ang fs niyo equals 1, okay? Ang corresponding f of t natin dyan ay nakalagay doon u of t, pero again, i-consider natin siya as 1. Okay? So, ayun. Ito naman pangalawa. Okay? Kung ang f of s ninyo ay 1 over s plus 4. Okay? Ang magiging transform natin dapat dyan is an exponential. That is e raised to negative 4t. Okay? So, ma-verify nyo yan dun sa table ulit natin, sa table 1. Okay? Pero kung 2 ito, if this is 2, nakamburahin na natin yun. If this is 2, okay, then ito, magkakaroon din ng factor 2 kasi ilalabas nyo mo ito bago nyo yung inverse. So, ito yung lalabas dun. Okay, and then finally, ito, f of s equals 1 over s plus 8. So, ang f of t natin dyan is, again, e raised to negative 80. Okay, so lahat ng ito nandun sa table 1. Okay, hanapin na lang natin. So, ngayon, adding the results, okay, again, ang inverse ng y of s ay y of t. Okay, so ito would lead you to the inverse transform ng 1. Ito naman would lead you to inverse transform of negative 2 e raised to negative 40. And then finally, ito would lead you to an inverse of e raised to negative 80. Okay? So, ngayon, actually, kung ito ay solve nyo sa using elementary methods ng differential equations, medyo mahaba-haba ito ng konti. Although, dahil yung initial conditions nyo ay 0, hindi siya kasing haba nung ginagawa nyo before. Okay? Medyo mas maikli naman ito kumpara doon sa talagang ginagawa nyo before na merong initial conditions. Okay? So, pero still, mas maikli pa rin yung Laplace transform solution kumpara dun sa mga methods na ginagamit natin before sa differential equations natin. Okay? So, ayun. And, yun nga, yung sinasabi natin, pinapoint out natin that the Laplace transform actually has the power to do that. Has the power to translate yung problem natin sa differential equations into algebraic problems. Kasi, kung papansinin nyo, after taking the Laplace transform, yung kasunod ng solution nyo, puro algebra na lang yan. So, nung nakuha nyo na yung Laplace transform nung inyong, nung nakuha nyo to, yung Laplace transform nung equation ninyo, pagkatapos nito, algebra na lang yan eh. Puro algebra na lang yung part ng solution ninyo. Okay? Except lang dito kasi ito, sabagay algebra din 'to kasi nga titignan niyo lang naman 'to dun sa table. Okay? Lookup table lang naman 'to. So, ayun. So, this is how the Laplace transform actually eases the solution of differential equations when it comes to the problem of solving constant coefficient differential equations. Okay? So, I hope this is clear to everyone. Okay, watching this lecture. Okay, kasi kailangan natin yung part na yan. Okay? Now, let's proceed with the next topic, okay, which is the transfer function. And speaking of which, saglit lang ulit may check lang ako. Okay. So, continuing. So as I discussed earlier, tungkol sa transfer function, it has a distinct advantage of allowing us, okay, to separate yung input signal ninyo sa system ninyo at saka dun sa output signal ninyo. Okay, so in terms of a block diagram, ma-separate natin yung tatlong quantities na 'yon. Tatlong quantities na 'yon. Yung input signal ninyo, R of t, okay? At saka yung output signal ninyo. So, you have your input signal or tawag natin reference input, R of t. And then, yung inyong control variable. Or essentially, yung inyong response. Okay? As C of t. Tapos, ito yung system niyo. So, separate natin yung tatlo if we actually use transfer function, okay? If we use transfer function to model your system. Okay? So, paano nyo gagawin yung separation ng tatlong quantities na yan? Okay, ganito. I also stated earlier na ang system ninyo, wait lang. Shh! Wait lang, wait lang. Hugo! Ayun, sorry for that. Napasigaw pa tuloy ako. Okay, so again, ang problem natin dito sa part na 'to is that we would like to know kung paano yung transfer function niyo can actually separate these three. Okay? Paano niya maihiwalay itong tatlong 'to. Okay. So, again, as I stated before, yung system niyo can be represented by differential equation. So, ito yung differential equation niyo. So makikita nyo ngayon na ang fundamental problem dyan ay magkakasama yung C of t. Okay? Magkakasama yung C of t, yung R of t. Okay? Tapos yung itong mga coefficients na to, these coefficients actually describe your system. Kumbaga, depende sa behavior, depende sa internal characteristics ng system niyo yung mga coefficients na yan. So, yung characteristics ng system niyo are modeled on those coefficients. So, dyan, ito yung sinasabi natin na kapag ang representation ng system niyo is in terms of a differential equation, magkakahalo lahat. Okay? Nakahalo yung system characteristics niyo dun sa mga signals. Dun sa input and output signals niyo. Okay? So, now, ang gagawin natin ngayon dito with equation 4 is we will get yung yung Laplace transform nito. Okay? So, kunin natin yung Laplace transform nung equation 4 ngayon. But remember that when we take the Laplace transform of that, i-consider natin na yung initial conditions natin ay 0. Okay? So, when we get the Laplace transform of that, ito yung makukuha natin. So, para dito, okay, we will have an times s raised to n, okay, times c. Where c here, uppercase c, is yung Laplace transform nung lowercase c. Okay? So, again, s raised to n yan. Okay? That's s raised to n kasi we are taking the Laplace transform of nth derivative. Okay, tapos tong a of n na to, an na yan ay constant. Okay, so next term, okay. Again, wala na tong kasunod na term kasi nga, zero initial condition. So yung mga initial condition terms niyan, lahat yun, zero na. So yan lang talaga yung may iwan. So in this, for the next term, okay, we will have an to n minus 1 multiplied to uppercase c. Again, c here is the Laplace transform of this c. Yung power ng s ninyo is n minus 1 dahil ito ay n minus 1 derivative. And ito, constant ito. And so on, until makarating tayo dun sa last term natin. Okay? Which, yung Laplace transform niyan is simply A0, okay, times C. Kasi yung Laplace transform ng CT natin is simply C of S. O rin na nga, C. Okay? So, yan. That's yung left side. Yung right side naman yan, okay, ito. So, ito. Okay? That would be B sub M, okay, multiply to S raised to M times R. Okay? So, yung R dito, this R, is yung Laplace transform nitong R of T. So, R of S yan. Ginawa ko lang muna ng R. Okay? Yung power ng S dito, which is M, is because of M derivative. Okay? And yung Bm dito is the constant na to, B sub M. Again, yung initial condition terms nito, lahat yun, 0 na. Again, because we're solving this for zero initial conditions. Okay? And then plus B sub M minus 1 multiplied to S raised to M minus 1, then multiplied to R. And so on, until you'll have, sa dulong term, okay, we'll have B sub 0 times R. So, yan yung magiging Laplace transform ng equation 4. Okay? Ang gagawin natin ngayon dyan, after which, is to factor out. Okay? Ipa-factor out natin yung C sa left side. So, ipa-factor out natin si C sa left side. Okay? Tapos, sa right side naman, ipa-factor out natin si R. Okay? Ipa-factor out natin si C sa left side, tapos ipa-factor out natin si R sa right side. Okay? So, pag pinactor out natin si C sa left side, i-factor out natin si C. Ang may iwan dyan is ito, A sub N, S raised to N. Okay? Plus ito, A sub N minus 1, S raised to N minus 1. And so on, until yung last term is simply A sub 0. Okay? So, ito na yung C. While on the right side, okay, pa-factor out natin si R. Okay? So, ang may iwan doon sa first time ay ito. So, B sub M, S raised to M. Okay? Then, sa second term, ito, yung may iwan dyan, that's B sub M minus 1, S raised to M minus 1. And so on, until yung last term na may iwan is simply B sub 0. Okay? So, ayan. Now, the last step na gagawin natin dito is to take the ratio of C of S. Again, itong C dito, that is in actuality or in reality, the C of S. Okay? So, sinusulat ko lang siya dito as C para lang hindi siya masyadong hindi masyadong makagulo yung of S dito. To, ganun din to. This is actually R of S. Okay? That's actually R of S. Okay? So, isi-solve natin yung ratio ng C of S over R of S para dito. Okay? And in that case, we can see that ratio, okay, para makuha natin siya, itong left side, i-divide natin, itong equation, i-divide natin with this, with this thing. Okay? Tapos, i-divide natin ulit yung entire equation with R. Para yung R mapunta dito sa left side. Tapos ito, mapunta doon sa denominator ng right side. So, ang lalabas ngayon dyan is ito muna, yung B sub M, S raised to M, plus B sub M minus 1, S raised to M minus 1, and so on, until the last term is simply B sub 0. Okay? And then yung denominator is A sub N, S raised to N, plus A sub N minus 1, S raised to N, N minus 1, and so on, until the last term is A sub 0. So, ito ngayon, itong ratio na nakuha natin na to. This ratio na nakuha natin. Yan yung tinatawag ngayon natin na transfer function. Okay, this is now what we call the transfer function of your system. Yung ratio na to, minsan tatawagin natin yung G of S. Okay? In the context of what we will be talking about, that ratio, C of S over R of S, is G of S. Okay? So, ito yun. Yan yung nandito ngayon. Okay? So, with G of S G of S here is now called the system's transfer function evaluated at zero initial conditions. Ngayon, since meron na tayong description ngayon nung system ninyo, okay, yun yung gagamitin natin ngayon dun sa block diagram ninyo. So, ito ngayong nasa loob ng block diagram nyo ngayon dito is now your G of S. Okay? Will now be your G of S. Now, as you can see now, mahihiwalay nyo na ngayon ito, at saka ito. Sa paanong paraan? Tandaan natin that G of S, okay, is equal to C of S, okay, over R of S. Pero, if we actually solve this for C of S, okay, may express natin siya this way. That is, C of S, okay, will be the product R of S times G of S. Okay? And ano yung C of S? At saka yung R of S. We remember that R of S is actually the transform of the input. Ang input natin ay R of T. Okay? Yung transform ng input R of T natin is R of S. But, okay, so tandaan natin ang input signal nyo is R of T. Okay? So, yung R of S ngayon is considered as the transform of the input. But, okay, tatandaan nyo rin ito. At this point, we will also call R of S as an input. Okay? Technically, medyo may konting inaccuracy dun sa term na gagamitin natin. But, basta tandaan lang natin na ang input natin lagi is in time domain. So, it should be R of T. Okay, it should be R of T. Pero in the context of what we will be talking about, then let's consider R of S also as an input. Pero pag kailangan natin yung input signal talaga, then yung R of S natin, kailangan yung i-inverse Laplace transform para makuha nyo yung R of T. Okay? So, yun. Ganun naman yung, yung usapan natin. Pero still, we can refer to R of S as the input. Okay? And then, also, we will have to have your C of S as the transform of the output. Okay? To transform the output. But remember that again, your output is C of T. Yan yung output nyo talaga. So, yung transform ng C of T is C of S. Okay? And again, katulad ng logic na gagamit natin sa R of S, we will still refer to C of S as your output. Okay? Provided na nagkakaintindihan tayo na kapag kailangan nyo talaga ng output signal, then that should be C of T. So, kailangan natin kunin yung inverse nung C of S to get C of T. So, ngayon, kung mapapansin nyo ngayon dito sa product na to, sa equation 6 ninyo, na natabunan ko na, okay, the output is actually the product of the input and the transfer function. Yan yung mapapansin nyo dun sa system niyo. At yan ay kung titingnan nyo sa block diagram, mas lalong magiging obvious yung separation niya. Kasi kung titingnan nyo, kung R of S ito at G of S ito, then C of S is simply G times R, or R times G, sorry. C of S is simply R times G. So, ibig sabihin, kung babasahin nyo lang itong block diagram niyo, parang ang nangyari lang, itong block diagram niyo na to is actually causing it to be multiplied. Yung description ng block diagram nyo is to be multiplied to the input para makuha nyo yung output niya. Okay? So, it should make sense kasi kung sa electronics natin, kung meron tayong amplifier na ang gain ay A, so kung meron kayong input signal dyan na X, okay, ang output natin dyan ay A times X. Okay? So, ganoon din dito sa part na to. Pero this time, we're having a dynamic system. Ibig sabihin, hindi constant yung output niya. Or hindi constant yung characteristics niya. Hindi katulad dito. Constant yung characteristic niya. Yung gain niya, laging A lang. Okay? Pero ito, hindi. Iba yung characteristics niya, nakadepende rin sa time. O nakadepende rin sa mga coefficients niya. Okay? Mali yung sinabi ko na nakadepende sa time. Nakadepende sa coefficients niya. Okay? So, yung logic ngayon dito is that to get now the output, you need to multiply the input to the system characteristic. Okay? So, medyo obvious yan dun sa block diagram na meron tayo. Okay? So, ayun. So, and that is the thing na pinag-uusapan natin earlier on pa, that your block diagram, your transfer function as used in a block diagram can be used to separate yung input signal, yung system characteristics, at saka yung output signal. Okay? So, ngayon, separately, yung G of S ngayon is just the system itself. Okay? Wala na siyang kinalaman or independent na ngayon siya dun sa R of S. Sorry. Sa R of S at saka sa C of S. Hindi katulad kanina na yung dun sa differential equation nyo, magkakahalo-halo sila. Yung mga coefficients kasi niyan ang mag-determine ng system characteristics eh. Tapos yung C of T at saka yung R of T nakahalo dun sa mga. So mahirap siyang interpret intuitively. So in this case, yun. Mapagaan tayo, maaanuhan natin, masiseparate natin siya. And mas magiging madali yung mathematical tools. Mas magiging madali yung mathematical manipulations na gagawin natin for this one. Okay? So there. Now let's have example 4. Okay? Let's have example 4 in which we are asked to find the transfer function of the system represented by this differential equation, assuming zero initial conditions. Okay. In the future, baka hindi na natin banggitin ng paulit-ulit itong zero initial conditions. Okay? Sa class natin, okay, in our class, we will always assume that your system is are operating with or from zero initial conditions. Okay? So, yun, baka hindi na siya mabanggit. Pag hindi siya nabanggit, yun yung understanding natin lagi. Okay? So, yun. So, that's the first problem, no? Let's find the transfer function. And then yung second problem kasi dito is to find the system response. System response means output. Okay, so meron kayong input ngayon na R of T equals U of T. Okay, pinapahanap yung C of T para sa system na to. So, mag-assume tayo na may input tayo ngayon na U of T. Okay, so first, dun muna tayo sa transfer function. So, when we want to find the transfer function galing sa differential equation, tulad ng step na ginawa natin kanina, we started with finding the Laplace transform of your differential equation, assuming zero initial conditions. So, itong term na to magiging ganito. Okay? Then itong term na to magiging ganito. Okay? And then ito, yung R of T magiging R of S. Okay? Now, after which, isolve natin ngayon yung ratio C of S over R of S kasi ito yung transfer function ninyo. This will be your transfer function G of S. Okay? So, para magawa natin yun, yung S times C, inside the C of S, gagawin mo ng C. Okay? Plus 2C equals R. Okay? I-factor out natin si C para makuha natin yung S plus 2 dito. And then, equal siya sa R. So, ngayon, yung ratio na C over R is obtained by first dividing this with S plus 2 para mawala siya dito. And then, second, dividing everything with R para ito mapunta sa denominator nito. So, we'll now have C of S over R of S equals 1 over S plus 2. So, ito yun. Okay? So, that is your system's transfer function. Okay? Now, the second part of our problem is to find the system response to the step input. So, yung tinatawag, pag ang input natin ay step signal, Okay? Kasi hinahanap natin yung response ng system ninyo to that step signal. Okay? Collectively, ang tawag natin doon, step response. Okay? So, ang step response is the response or is the output, okay, output of your system to a step input. Okay? So, tatandaan niyo kasi at a future point, at some future point, lagi din natin gagamitin yung term na step response. Okay? So, here, para mahanap natin ngayon yung step response na yan or yung response or yung output ng system niyo to the step input, then gagamitin natin yung equation na to. Okay? Itong equation 6, bale. Itong equation 6 natin, bale, gagamitin natin siya. In which this is C equals R times G. Okay? So ngayon, we take note that R of S, okay, is actually ito na pala. Yung R of S natin, okay, is actually the Laplace transform of R of T. Okay? And ang R of T natin is Q of T dito. Okay? So, from table 1, okay? From table 1, nakalimutan ko lang kung anong item, pero number 2 yata ito, item 2 or row 2 yung table 1 ninyo. Yung Laplace transform ng U of T ninyo is 1 over S. So therefore, yung R of S natin is isa-substitute natin yung 1 over S para sa R of S natin. Tapos yung G of S natin, yung nakuha natin dito, which is 1 over S plus 2. Okay? So that yung C of S natin ngayon, okay, has the form 1 over S times S plus 2. Okay? Pero again, sabi nga natin, although we will call C of S as an output, technically it is still the transform of the output. Okay? It is still the transform of the output. So, that should mean na kung kailangan talaga natin yung output or yung response ng system niyo, we have to get the inverse. Okay? We have to get the inverse of the transform of the output para makuha natin yung saktong expression para sa response or yung step response ng system niyo, which is C of T. Okay? And for us to do that, ang kailangan nating operation is the inverse Laplace transform. So kukunin natin yung inverse Laplace transform nito. So and to evaluate now the inverse Laplace transform of your C of S, since again yung denominator, observe natin na product siya ng dalawang linear factors, S, okay, S at saka S plus 2. Okay, S at saka S plus 2. Okay. So, ngayon, magpa-partial fraction expansion tayo by having this one, okay, having this as your first term, okay, and then this one as your second term. And then we need now to solve for A and B by cover-up method. So, yung A is obtained by having this, okay, 1 over S plus 2, when S is equal to 0, so that's 1/2. Okay? And then B is obtained by convert natin yung S plus 2. So may iwan dyan 1 over S. And then evaluate 1 over S when S is negative 2. So that gives us negative 1/2. So now we can write this. Okay? We can write now your C of S as 1/2 over S minus 1/2 over S plus 2. So ito ngayon. Okay? So ngayon ito, yung inverse nito is obtained by, tabi natin muna yung 1/2. Tabi natin yung 1/2. Tapos kuha natin yung inverse ng 1 over S. Ang inverse ng 1 over S ay simply 1 as per, ito 1 lang to. Galing, check nyo sa table 1. No? Okay, yung kabila naman, again, tabi natin yung negative 1/2. Kuha natin yung inverse Laplace transform ng 1 over S plus 2. Okay? And again, checking it from table 1, makukuha natin na yung inverse nito as e raised to negative 2t. Okay? So therefore, 1/2 times 1, yung first term nung response ninyo, And then, negative 1/2 times e raised to negative 2t, yung second term ng response niyo. So now, this will be your step response. Yan yung magiging step response natin. Okay? So, there. Now, working now on example, on example 5 naman, yung mga lumalabas ng mga writings dito na. Okay. So we now work on example 5 in which we are asked to find the differential the transfer function that corresponds to this differential equation. Okay. So simply, pagka ganito, ang kailangan lang naman natin gawin is to take the Laplace transform of the entire thing. So yung Laplace transform nito, again, zero initial conditions tayo. So yung Laplace transform niyan is this. So instead na C of S ang ilagay ko, C lang muna. Okay. Pero still, C is C of S. Okay. So, yung inverse nito, I mean yung Laplace transform nito is this one. Okay. Yung Laplace transform nito, okay, is this one. And yung Laplace transform, ano bang kulay hindi ko nang gamit dito? Wala akong blue. Ayan. So, yung Laplace transform nito, at ang kapal niya. Yan, yung Laplace transform nito is this one. Then, on the right side, ganun din. So, yung Laplace transform ng first term niyo, this one. Okay. Next, yung Laplace transform ng second term, this one. And finally, yung Laplace transform ng last term, this one. Okay. Then, after which, factor out niyo yung C, factor out niyo yung R sa left and right side respectively. And then, simply solve for the ratio. So, that will give you the transfer function. So, ito na yung magiging transfer function natin ngayon. Pero kung papasinin nyo mabuti, okay, kung papasinin nyo mabuti, makukuha nyo to by just mere observation of this one. Okay? Kung matatandaan nyo, yung numerator, di ba, C of S over R of S ito, no? Yung numerator ng C of S at saka ng R ng yung numerator ng C ng transfer function niyo. Itong nasa taas is actually a polynomial based on coefficients B sub M up to B sub 0. Or polynomial yung based polynomial whose coefficients are yung B sub M hanggang B sub 0. At yan ay nandun sa right side ng equation niyo. So from there, ang coefficients nito, since ito ay square, so magsisimula kayo sa S square. Okay, so ang coefficient niya ay 1. So 1 times S square plus 4 times S plus 3. That's the numerator. Yung denominator niyo naman ay essentially, okay, this is essentially the polynomial, okay, whose coefficients are A sub n up to A sub 0. Okay? So, ayan. So, ibig sabihin, itong S cube na to, nakuha yan galing dito. So, 1 times S cube. Ito. Okay? Yung 3S squared na yan, nakuha yan dito. 3 times S squared. Plus 7 times S plus 5 and so on. So, ayun. So, intuitively, makukuha natin siya actually galing dun sa differential equation nyo without actually going through everything. Okay? So, yun yung prime advantage nung ating Laplace transform pagdating sa ganitong system modeling. Okay? Now, in example 6, balik rin naman, meron kayong transfer function. Ano yung differential equation that actually represents it? Okay? So, ito, without looking at this, the solution, again, by intuition, the numerator is from b sub m up to b sub 0. The denominator is for a sub n up to a sub 0. So, yung differential equation dito is actually the second derivative of c with respect to t. Para yan sa s square dito. Plus 6 times the first derivative of c with respect to t. Yan yung 6s. Plus 2 times c. Okay, yan yung 2. Equal yan dun sa numerator natin is 2 times the first derivative of r with respect to t. Okay, plus r. So, yun yung magiging differential equation natin. Okay, pero ito yung actual solution yan. Ito, kinuha lang natin by intuition. By observing what is happening with these things. Okay? So, let's continue on. Let's find the ramp response of a system whose transfer function is this one. Okay? So, ayan. Ramp response. Ibig sabihin ng ramp response, the response of the system to a ramp input. And kanina nabanggit ko while in the discussion of table 1, yung ramp input natin is t u of t. Okay? So we are looking for the output or the response of the system na to. Okay, to a ramp input. Okay? So the ramp response, okay? The ramp response of a system is the output of that system to a ramp input, which is ito na nga. Okay? So, pag naghahanap tayo ng output, okay, or ng response, we rely on equation 6. Okay? Which is this one. Yan yung equation 6 natin. Now, in this case, yung G, ito yun. Okay? But in this, but our R, okay, our R is the Laplace transform of our input ramp. So, kukunin natin yung Laplace transform nito, which is by table 1, yun nga, yung 1 over s square. So, kung 1 over s square itong r natin, ito yan, then i-multiply natin siya dun sa g, which is this one. So, that becomes, when we simplify this thing, okay, kasi magka-cancel to, tsaka yung isa nito isang degree nito. Okay, or yung isang factor nito. Then that becomes 1 over s plus 4 times s plus 8. Okay? So, ngayon, since we're looking for the ramp response, that would be the inverse of your C. Yung inverse nito. Okay? So, response ang hinahanap natin, kaya natin kunin yung inverse sa Laplace transform niya. So, again, when we evaluate the inverse Laplace transform of this, observing the denominator, kailangan nating mag-partial fraction expansion ulit. Okay? So, the partial fraction expansion is this one. A over s plus b over s plus 4 plus c over s plus 8. So, by cover-up method, verify nyo na lang na ito yung lalabas. We have this one, okay, this one, and this one. Okay? So, napag-usapan na natin yung cover-up method kanina. Okay? So, verify nyo na lang from the previous discussion na yan yung lalabas sa sa cover-up method natin. Okay? So, now that gives us, ito, 1 over 32 daw ito. This is 1 over 32. Ang B natin is negative 1 over 16. Ang C natin is 1 over 32. So, ito siya. So, we will have 1 over 32 over S minus 1 over 16 times S plus 4. And then 1 over 32 times S plus 8. So, by linearity, okay, and table 1, okay, labas natin yung 1 over 32. So, labas natin yung 1 over 32. Kunin natin yung inverse transform ng 1 over S. Okay? And by table 1, yung inverse Laplace transform ng 1 over S ay 1. So, therefore, lalabas dito, this is 1 over 32 times 1. Kaya, ito yung lalabas sa first term natin. Okay? Next, by linearity, labas natin yung negative 1 over 16. Then, kunin natin yung inverse Laplace transform ng 1 over s plus 4. As per table, so ito na yung negative 1 over 16. Now, as per table 1, yung inverse Laplace transform daw nito is e raised to negative 40. So, kaya ito yung lalabas dun sa second term natin. Okay? And then finally, yung ating 1 over 32 over s plus 8, labas natin muna yung 1 over 32. Kuha natin yung inverse transform ng 1 over s plus 8. Okay? As per table 1 ulit, ang inverse Laplace transform ng 1 over s plus 8 is e raised to negative 80. So, kaya ito yung lalabas sa third term natin. So, we will now have this as your, ito na ngayon yung magiging ramp response niyo. So, ramp response of G of S. So, in general, a physical system that can be represented by a linear time invariant differential equation, that can be represented by a linear time invariant differential equation can be modeled as a transfer function. As long as the system is linear and time invariant, okay, or as long as the differential equation is linear and time invariant, okay, it can be modeled as a transfer function. Okay? Now, in the next lessons, pag-usapan sana natin yung, or i-demonstrate sa inyo kung paano ngayon gamitin yung transfer function, okay, in order for us to model electrical networks, mechanical systems, and electromechanical systems. Yung electromechanical system na yan, simply that's just a motor. Okay, that is used to build systems na gumagalaw. Okay? So, ayun. Now, I would like to tapos na yata itong part na to. Okay, tama. Tapos na. Okay, so next dapat na dyan is itong transfer function of passive electrical networks. Okay, so, but the thing is that it's already 6:30 and meron akong meeting kasi by 7 p.m. Okay, so I would like to request the understanding for your understanding na I'll have to cut the class at this point because may mga